In this video, I want to describe how to create an Excel spreadsheet for production planning. So what is production planning? The definition is the administration process that takes place within a manufacturing business and which involves making sure that sufficient raw materials, staff, and other necessary items are procured and ready to create finished products according to the schedule specified. A typical large manufacturer engages in production planning will aim to maximize profitability while maintaining a satisfied customer base. In our particular learning activity, what we'll examine is a production plan for a 6-month time horizon. So essentially, we will have a schedule for the amount of products that we actually intend to manufacture over 6 months, the amount of hires that we plan to hire, and actually how many layoffs we actually intend to have over the 6 months. The objective here is to develop a capable spreadsheet in order in such a way that we can actually examine various production plans, because essentially if you were a production planner, you would have to take a look at alternatives in terms of keeping your profits high, which usually means lowering your cost and actually satisfying the customers so you don't have any situations where you are not able to satisfy orders. So let's go ahead and start this learning activity by opening up the starting file. Okay, when we open up the starting file, we see that basically there's a lot that has been filled in for you. And the first initial table that I have the initial information. So essentially, we're in a situation where it's December and we're trying to make a plan for the next 6 months. So we have January through June. The information here is going to dictate the entire spreadsheet calculation. So these variables could potentially change. Now, given that we want to develop a robust spreadsheet that is dynamic in nature, these are the only values that we can allow users to change. Anything else besides our production plan, anything besides these two fields that I have highlighted here, are going to be calculated fields. So we don't want to embed numeric constants in any of these fields. We want to be able to start changing these numbers in the highlighted field and everything below here. For example, the inventory levels, the worker information as far as the number of hires and fires and or layoffs, and the total number of workers given in a month, the labor hours for those employees, the labor cost in terms of what we have cost for. So we do have total cost and things like that. So essentially what we have is a field where it's desirable that you separate this information so that these values can easily be changed later. For example, overtime cost might actually increase from $23.75 an hour to just $25 an hour, and we want all of these calculated cells below to reference all of these cells above. So in terms of the production plan itself, we have this table here. We have the 6 months, January through June. We have a forecast, if you will, of the units that will need to actually produce. This could be a forecasted value, or it could just be what we have contracted out right now. In terms of this production plan, we have a monthly demand, and then we have both a regular and overtime production. So right now, this is just a hypothetical schedule. So it's not necessarily an optimal schedule. So there could be potential problems that we want to identify. But that's the idea of developing a robust dynamic spreadsheet, is that we can catch situations where perhaps we're not meeting our production goals and things like that. We do have the number of hires. So potentially we have people coming into our facility, and we do have other people that are going to be laid off. And the idea is that given the hires and fires, it's actually going to cost us $2,400 every time we hire somebody and it's going to cost us $1,750 every time we lay off people. So there's going to be costs associated with both hiring and firing, and usually what happens is we try to balance out the hires and fires in such a way that we have a stable workforce and one that keeps our costs down, and so we're able to meet our goals in terms of our productions. So the following table would be our inventory table, beginning inventory. That's actually going to be referenced to the table above, regular production, overtime production, and so forth. So you actually might be wondering why there is so much duplication, but we will see that we are trying to develop a spreadsheet, and users actually won't be even able to access these fields once we're done with this activity. There's no reason to. These are all formulas. So let's go ahead and start working on this activity by working on the inventory table in cell B21. Okay, for the month of January, we do have a level of beginning inventory. Now that is actually going to be referenced from the table above. So again, we're assuming this is December and we're planning the next 6 months. So from the table, we have an initial inventory of 75 units. I'm just going to go ahead and reference that 75 units and even put a $sign, even though I don't have any intentions of filling this formula to the right, which I'll explain later. We have a regular production. That regular production is going to come from our schedule of 400 and our overtime production of 25. Now, when we just looked at this initially, we do have a demand of 450. And you might have questioned, well, why are we only making 425 units in the first month when we in fact needed 450? Well, again, this is an idea where we have inventory coming in, so those extra 25 units are going to come from our inventory. Okay, so let's go ahead. Total production then will be a sum of the regular and overtime production. So again, we do have duplication. For example, the information of regular production and overtime, we could actually fill these formulas to the right because they will never change. However, our beginning inventory will, but I don't want to get too far ahead of myself. So I'll just delete that for now, but these formulas will always be the same. Total production will actually be the same. The demand is going to be referenced up to the demand in the table of 450. And again, the idea is that yes, we do have sort of an overlap of information. We could have just referenced some of this information in our, let's say, ending inventory cell, but sometimes it's actually a good idea to repeat information so it's all logically together. For example, my ending inventory will be equal to the number of units that I have at the start of the month, which is my beginning inventory, plus the total production that I'm going to receive from overtime and regular time, and then I'm going to subtract out the demand that I have. So I have 50. I have 50 units remaining after I took the 25 that I needed out from the inventory. Okay, that's actually good. The next month we have to say, okay, what is the beginning inventory? Well, this is actually just going to be referenced not to the table above like we did last time, but actually to the inventory level of the last month. So this will be 50. At this point, this pattern will always stay the same. So we can actually fill this formula to the right. So the beginning inventory of June will be based on the inventory level at the end of May. So similarly, when I look at this formula, these references are only referencing the aggregate plan above, or the production plan. So I can fill this one to the right, and actually I can fill the remainder to the right. It's just this first one about beginning inventory and the beginning of the inventory next month that is just slightly different. Okay, so let's move on to the worker information. I do have a field here that I'd like to reference hire, so I can reference the value hire in B17. Layoffs, in this case, will be 1 from B18. And workers, so what I have here is going to be equal to the number of workers that I have to start, which will be 12, plus the number of hires that I could potentially have, minus 1 layoff in this case, so minus the layoffs, equal. Now for these two formulas, I can fill to the right because they only reference that table above. And yes, I could have presented this in a way where these two rows were deleted. I don't necessarily need them to calculate the number of workers. I could have just had one row for this. But again, it's okay to duplicate your information as long as they are cells and the meaning stays the same. So if I was looking under the worker information, I could get all the information I want as far as the workers, even though hire and layoffs is a direct copy of this portion of our aggregate plan. In terms of the number of workers in February, we would have this equal to the number of workers that we left off with the prior month plus any hire minus any layoff. So we have 10. And we can fill this pattern, this formula, to the right because the pattern will actually stay the same. So in March, we take the number of ending workers, if you will, plus any new hires minus any new layoffs. Okay, next table we got to look at is the labor hour table. We have two categories here: regular hours needed and overtime hours needed, and then regular hours available and overtime hours available. I'll describe what I mean by problems in just a second. Okay, now we go down to the next table, the regular hours needed. And remember, our production plan is going to consist of a regular production and an overtime production plan. So we actually have two things that we're scheduling, essentially, we're planning for. The regular hours needed will be based on the regular production of 400 units times, and if we go up to the table above, it's going to be based on the fact that the unit hour, the hours per unit, is going to be 3.75. So I need 3.75 hours for every unit I produce. So I'm going to reference that and use my dollar signs to lock the position because I don't want that reference to change. So in the first month, I need 1,500 hours for the production of 400 units. I can fill this formula to the right. It'll never change. Overtime is going to be a very similar formula. Equals the amount that we have scheduled for overtime production, 25, times the 3.75 that is needed per part. So we have 93.8 hours. Okay, now we need to calculate what's available. And you might be asking, well, why do we need to calculate that? Well, it's because it could be a situation where we don't have enough employees to actually manufacture these parts. We could get in a situation where we only have 1,400 hours available and we actually needed 15. So that would be a situation where we could have afforded to hire somebody, let's just say. But in this case, let's calculate what we have here for regular hours available. We have a situation here where we have 11 workers. Each one of those workers can work 160 hours. So we have a total of 1,760 hours that can be worked as a regular time wage. What about overtime? Well, we still have those 11 employees times their limited overtime hours per month, which is 25. So actually I have 275 hours available for overtime in January. And once we have that calculated, we can bring that formula to the right. Okay, so what I saw there just looked fishy, I guess, based on my experience. I saw all these zeros and I didn't expect that. So I immediately double clicked this cell and I looked visually to inspect my references. I saw the blue here, which was fine, and then I went up and said, oh, guess what? I forgot to use dollar signs. So let's go back to the initial formula, put our dollar sign in and hit enter, and fill the new formula to the right. Okay, problems. What do I mean by problems? Well, again, it's when we have a situation where we have some hour level that's needed and we actually have less hours available. So the formula that I'm going to write here is going to be equal to if the logical test. And I have two logical tests I want to use. So I'm going to use the or. And in either situation that this is actually a result of true, I want to report a yes. So I have two situations. One where I have the regular hours and the other where I need to check the overtime hours. So if, and then the or comes in because I have two conditions. If either one breaks, or if either one is insufficient, I want to go ahead and report a true and then report a yes. So if the hours needed are going to be greater than the regular time hours I have, that's going to be my first check. The second check is that the overtime hours needed, if it's actually greater than the hours I have available for overtime, that's going to cause a problem too. So it might take a few minutes to digest this logic, but essentially I'm just checking two situations. I want to make sure I have enough regular time hours, and I want to make sure I have enough overtime hours. And if this logic is true, I'm going to say yes, there is a problem. Else, no, there is no problem. So here we have no. So let's think about this from a visual point of view, or just think about it from a logical point of view for just a second. We have 1,500 hours needed, but we have 1,700 of hours available. So we have actually an excess of hours available. Similarly, we only needed 93 hours of overtime, and we have 275 available. So we have no production planning problems whatsoever. We could actually utilize conditional formatting, which is always a good idea, I think, in these more complicated planning problems. Why don't we say that we're going to highlight situations in the needed where we have a problem. So I'm going to start with this 1,500 and I'm going to go to conditional format, new rule, formula, and basically say the same thing that we wrote in the formula here. If needed is greater than available, I'm going to report this as a red fill. So I'm going to go ahead and make this a red fill, but there's one thing I need to do before I hit OK. The thing I need to do is take away these dollar signs because this is in an absolute fashion, and we want to be able to fill this format to the right and actually fill it down. So I'm going to take all those off and hit OK. This is not red because we're not in a situation where we have problems. Let's copy this formatter and bring it over. So we do have one issue here. We can go ahead and drag this formula to the right and actually look. It does look like we have an issue with we need 2,062.5 hours, and the only thing we have available is 1,900. So this is a situation where we do have a problem, which is indicated visually through the conditional format and as well as the yes/no here. Once you have this conditionally formatted, we can simply copy that format and bring it down to overtime because it's in a relative position. We have regular hours needed and then 2 rows down regular time hours available. Well, similarly, we have the overtime hours needed, and then 2 rows down we have overtime. So it's in relatively the same position of the checks. So we're okay. We can just fill that down. So we have 3 situations where we have problems. 1 with regular schedule and 2 with the overtime schedule. Okay, now let's talk about cost. And I know this actually says labor cost, but there's actually more to it than just labor. So I'm actually going to delete this. It probably was a copy and paste from above, and I didn't remove hours, so I apologize. So labor cost for regular time. Well, we know for a fact that every employee gets, let's see, the regular wage in the table is regular wage cost per month of $2,500. Let's use our dollar signs, F4 key, and multiply that by the number of the number of employees that we have. Okay, so this is going to give us a total cost of $27,500. So this is like this because if actually we go back to the table, this is the regular wage cost per month per employee. The overtime, we only need to pay overtime when overtime is actually utilized. So it's a subtle difference between the 2 rows here. Now that is an assumption of this spreadsheet, is that we essentially don't pay out regular time hours based on the hours needed. We are more like a salary position where regardless if we need the hours, we're going to pay them regardless. So if we were truly operating in a situation where we only paid the hours that we needed, we would have referenced a per hour wage to the regular hours needed. But in this problem, we have the assumption that we do have 11 workers. Those 11 workers will get paid $2,500 a month. So overtime is just slightly different. It's going to be the overtime hour cost of $23.75 an hour. I'm going to use my dollar signs times. Now in this situation, we only pay for when we do have overtime. So we can reference the overtime hours needed of 93. And actually that's all we need to do. Let's fill these formulas to the right. Looks like we're okay. I don't see anything suspicious here. Hiring cost will simply be the number of hires that we have times the hiring cost of $2,400. Of course, we need our dollar signs, so we're going to put that there and fill this to the right. Okay, so only hiring cost in these 3 months. Layoff cost is going to be a similar fashion. We need to understand when we have a layoff. So that is referenced there times the layoff cost of $1,750. And of course we need our dollar signs there. So we can go ahead and fill this to the right. So only 2 months we're laying off. Inventory cost is going to be equal to the inventory holding cost, which is $12.25 per unit. So let's reference that, put a dollar sign around the row and column, even though we just need the column, but that's okay. Let's put both, times the number of our ending inventory of 50. So we can hit OK there, or enter, fill that formula to the right. And now total cost. Total cost in this situation will actually just be a sum of everything we have identified. So we have the labor cost, regular and overtime. We have the hire and layoff cost. And then, of course, the cost associated with our inventory. For this particular problem, that's all we're keeping track of. So let's hit enter for the total and fill this formula to the right. Now, if we wanted a grand total, we can certainly summarize that. So I'm going to say grand total here. I'm going to use the same format as the cost table. And the grand total would be calculated based on all of the monthly totals. So in this situation, I have $220,000, almost $221,000. I might also want to summarize the number of problems. And I could have just one, I could have more than one. So I'm going to document it like that. And I'm just going to simply do a count ifs. And I want to look over this range, the criteria range, and count how many times I see the letter yes. So in this case, my schedule that I am about to implement, let's just say in December, has 3 problems. Well, the idea is that we don't want any problems. So what I might recommend here is actually to either leave this here, but then you're going to be doing a lot of scrolling. I would actually move this to the top. And I'm going to put it right here. I think that's a good enough space for this. And after resizing everything, the idea is that I can change anything in this red table, even the monthly demand, but we should assume that this monthly demand is somewhat accurate. And the things that we are going to change could be strictly the number of units we're assigning to regular time and overtime, or the hires and fires. Of course, this information might change as well, which will directly affect costs, but these are pretty much constants we can assume. But if we're going to develop this sheet, we might as well develop it in a way that we can refer to these constants, because they might change in 6 months or a year and things like that. So the idea again is that this schedule is not perfect. We do have some errors. And if you were a production planner, you would actually go through this plan until you had 0 problems. Now, the trick and the skill of a production planner would be to try to get this cost to be minimized. So, for example, you would go through here and say, okay, well, I guess the only problem I have is in April. So what's the problem? Well, I needed 2,062 hours, and I only have the 1920. So does that mean, well, I just need to reallocate my number of units here? Maybe I can afford to actually do this in a manner where I can just schedule some overtime in April. Or how about we just employ one more person? So we might want to change the one here. Of course, that's not going to change this to a 2, I should have done. So that's going to directly increase our cost, but it's going to get rid of an error. So I'm going to actually undo that. I just wanted to demonstrate the functionality of why do you do this? What are the benefits of developing a dynamic sheet? Well, it's just what we're seeing here. It's that we can devise a schedule for, well, I should have highlighted this, a schedule that we can actually implement over the 6-month time horizon and actually be pretty sure that we're not going to run into production problems. And of course, we want to do this in a way that is cheap as possible. With that being said, there's only one more thing you might want to do, and this is related to people that might be using your spreadsheet or protecting yourself from making mistakes in a spreadsheet once it's all developed. Now, certainly there are some things that we could have done, but I wanted to keep the complexity a little bit on scope, because this is not necessarily an operations course. We could have added extra logic where in these formulas to prevent any situation where we might have negative employees or negative inventory or those types of situations, but that's okay. Let's assume that this spreadsheet is robust enough for our need. What we might want to do is protect this sheet and only allow users to change red cells. So you can highlight the red cells, red font cells, and go to Format Cells. And right now, these cells are locked if we protect them. So I'm going to uncheck the locked there. I'm going to highlight, right-click, go to Format Cells, uncheck the locked. And now, if we go to Review, and protect the sheet, this is going to say protect the worksheet and the contents of locked cells. So the red cells are no longer locked, and actually I'm going to allow my users to select unlocked cells. For this purpose, I'm actually going to password protect it too to OUMBA, all lowercase. Let's hit equals and go back OUMBA and hit equals. So now if you notice, I can't click on anything in the sheet except for anything in red that I've highlighted. So if I click on this formula for grand total, I can't. I've locked that and I've protected it. So all of these formulas here from essentially anything that's below row 19 is going to be protected, so I can't come in here and just over type a cell with a static number. For example, maybe I just wanted to come down here and say all our beginning inventory is 100 this month, and I should have updated that initial inventory figure here. So I will now prevent any problems like that from occurring since I have locked everything. And of course, these formulas will work. If I change this to a 2 like I did before, that formatting will go away and now I don't have a problem and things like that. But it's because I'm allowing users to select and modify these cells and nothing but these cells. And that's how you do it with the unprotect. If you did want to unprotect, you can simply hit this, type in the password, and go ahead and modify anything, which I could go down here and just write, maybe I'm just working on the spreadsheet and I hit some gibberish. Well, that's allowable in this state. But if I hit undo, and I don't want that to happen, I can go back to protect and protect it with the password OUMBA. And now that won't happen. I'm typing gibberish here, and actually it directed me to a cell that I could change, so that's okay.